I was 150 years old. In this lesson, we will have the techniques and applications of definite integration. Right, we'll be taking a look at this example we have. So you are seeing double integration over d, and your integrand is cosine x over square root x dx dy. So for this example, if you only had a single integration, let's say all you have is a single integration cosine x over square root x dx, that would actually be unsolvable. But now, since we have this double integration, we need to determine a specific boundary and a specific order in order to make it solvable. Alright, so first thing, we need to know what this graph looks like in order to determine what kind of a boundary we are going to use. And this boundary is between x is equal to y squared, x is equal to 1, and the x-axis in the first quadrant. Alright, so x is equal to y squared, which is also y is equal to square root x. Let's take a look at what it can look like. Alright, so x is equal to y squared, that means you're going to see something like this. Alright, and then x is equal to 1, and your x-axis, so that means the area would be this section over here. Right, so this is what we have. This is x is equal to y squared, this is x is equal to 1. And this point here, well, you can know it if you want, but it is pretty much just 1, 1. Alright? So, these are some of the things that we have. Now, as what we have said just now, if you want to integrate with respect to x first, it doesn't seem quite solvable. So, how about let's integrate with respect to y first. Now, what happens when you integrate with respect to y? So, y. That means we have to move or integrate from your x-axis to the curve. But this curve, it is x expressed it as a function of y. But if you want to integrate with respect to y first, we would need the function to be y in terms of x, which is y is equal to square root x. So this would have to go from 0 to square root x. And then what is the range for x? That will be from 0 to 1. Alright? So this is all we need to solve in order to solve this question. Right, so when you have two variables and you're integrating for one of them, you would essentially take all the terms with the other variable as constants. In this case, basically the entire thing is a constant. So you will only have a y out of this integration. Alright, so this is what you will be seeing. And next, you substitute in the values of y. So when you substitute in square root x, you realize you can simplify it with this square root x to get cosine x dx. But then when you substitute in 0, the entire thing is basically a 0, and you do not need to write anything for that. So when you integrate this part, you will have sine x and substitute in 0 and 1. Okay? So once again, substituting the values, then you just have sine 1, but sine 1 minus sine 0, and sine 0 is just 0. So sine 1 will be your final answer. Right, of course you can, depending on what kind of question you get, you can change it into decimals if you have a calculator, whatever. Okay, so this will be the answer you get for this question. Right, so what kind of methods do we use in this example? Now, in this example, first of all, we took a look at what this boundary, this range, this domain will look like. So by looking at what it seems to be, we can then more easily determine what kind of boundaries you would use for double integration. So when you change it into iterator integration, it would be much simpler to solve. Okay, next, well, you can add another step to change into iterator integration here, but otherwise you can just directly integrate, and after you integrate you will realize that this would just be a simple integration formula that it should be rather simple for you to solve, alright? So after everything, your final answer would be assigned 1. Right, so we're looking at another example for this lesson. So this example that you see here, double integration over the region of modulus x plus modulus y is smaller or equals to 1. And you have e to the power of x plus y dx dy. So once again, we will take a look at what kind of a boundary do we have. What kind of question are we dealing with, alright? So if you have watched some previous videos, you probably would see this modulus x plus modulus y quite a bit, alright? So if you still have no idea how to get the graph for this, you could go back to previous lessons to rewatch it and understand better, alright? So for this example, what we are going to have is, so you do have 4 separate functions that you have from this boundary that you have. So what exactly are your 4 different line graphs? For your first quadrant, that will be x plus y is equal to 0, or you could just write it as y is equal to negative x plus 1. While for your second quadrant, you have y is equal to x plus 1, and your third quadrant is y is equal to negative x minus 1, while your fourth quadrant is y is equal to x minus 1. Right, now this example, you do have 2 separate ways of solving it. And these 2 separate ways are whether you want to integrate with respect to x first, or do you want to integrate with respect to y first, alright? So those are 2 different methods that you can choose to use, but for now, we will take a look at what happens if you integrate with respect to y first. Alright. So when you integrate with respect to y first, let's take a look at the left side, alright? Now in the left side, when you go from your function in your lower half to your function in your upper half, that will be negative x minus 1 to x plus 1. And for your range for x, that would be from the leftmost side of your left half to the right side of your left half, which you will be seeing negative 1 to 0. Right, now let's take a look at the right half of your graph. So again, from your lower function to your upper function, you will have from x minus 1 to negative x plus 1. And your range for x would be from 0 to 1. And now that we know we are at this part, we can start integrating whatever we have inside here. So again, like the previous example, when you have integration for 2 different variables, when you're integrating for one variable, you'll take the other as a constant, alright? So this would just be a simple exponential integration. So in the first term, you are going to see e to the power of x plus y. And you have to substitute in y is equal to negative x minus 1 and y is equal to x plus 1. Then of course integrate with respect to x. Or for your second term, you will have e to the power of x plus y, and substitute in y is equal to x minus 1 and y is equal to negative x plus 1. Then again integrate with respect to x. Alright, so this is what we're going to see. Well, of course, we are going to substitute in the values for y. So, in your first term, you can split it into two separate terms. And the first one that you're going to see is e to the power of x plus 1, or just e to the power of 2x plus 1, then dx. Or for a second term, that would be, e to the power of x minus 1, which is e to the power of negative 1, then dx. Well, for your third term, you are going to have integrate from 0 to 1, e to the power of x minus x plus 1, which is just e, and then dx. Well, for the last term, you're going to have integrate from 0 to 1, e to the power of x plus x minus 1, so e to the power of 2x minus 1, and then dx. Right, so this is what we have to integrate, and they are pretty simple integrations. For your first and last term, the integrations for exponential, or for your second and third term, you are going to see that whatever you have inside here is actually constant. So, in your first term, you want to make whatever's inside your dx become the 2x plus 1, which means you're going to need an extra half and make e to the power of 2x plus 1 before you substitute in negative 1 and 0. Well, for your second term, you're just going to have e to the power of negative 1, x, substitute in negative 1 and 0. And for your third term, you're going to have ex, then substitute in the values 0 and 1. Last but not least, your last term, which again will be an exponential integration. So you're going to need a half, and a half e to the power of 2x minus 1. While also substitute in the values x is equal to 0 and x is equal to 1. Right, let's take a look at the first term you're going to have, which is half e to the power of 0 plus 1, which is still e. And the second part for your first term, you're going to have minus half e to the power of negative 2 plus 1, which is negative 1. So the first part of your second term would not be anything since it multiplies by 0. But afterwards, you're going to have a negative minus negative 1, which is still a negative. And this is e to the power of negative 1. For your third term, the first part of it, you just have plus e. For the second part, it multiplies by 0, so there won't be anything. While for your last term, you're going to have minus half e to the power of 2 minus 1, which is still e. And then plus half e to the power of 0 minus 1, which is e to the power of negative 1. And with this that you have, you can basically find that the answer is e minus 1 over e. Alright, so this is the answer that you're going to get for this example here. So if you realize, the methods are pretty much the same. You determine what your graph looks like, and after you determine what this looks like, you could easily find the boundaries, and with these boundaries then you can start your entire integration processes, sometimes using special methods, sometimes it's just as simple as this, using a normal integration formula. Alright, so that'll be all for this lesson. I hope that you can understand everything, and thank you for your watching.